we should be live. I just want to do a couple things first. Okay, I think we should be good. I'm hoping we're, yep, okay. Popped up on my second screen here. So, a couple days ago, I tried to fix this. It didn't work. Basically, what happened, well, it sort of works. It'll work for the first 30 seconds, minute so. And then eventually, what happens is, it just goes and shuts off. I don't think it shuts off officially, but I'm assuming the transistors are getting too hot and basically shutting off the output from the heat. So what that basically means is that we didn't end up fixing all of the problems, which means it still has a ways to go. So grab just that there. So I am going to be trying to fit this into my busy schedule because I'd really like this working, but basically I ended up just buying capacitors for the whole board. So we're gonna see if that works. There's gonna be a couple other things I'm gonna do. I should actually grab that first. I'm gonna grab Kapton tape. There's a screw under here that is basically, I believe it's hitting this relay, so that turns it off sometimes. So while I'm at it, I'm gonna Kapton tape that. Hopefully that'll stop it from doing anything, so it'll stop it from breaking the output or whatever. We're gonna have to watch the thermal paste because I don't really want to re-buy some, and I don't really have enough to repaste it all, or at least I don't believe. So we're gonna try to keep that clean, and we're gonna see if I can do this fairly quickly. We're gonna try to recap the whole board, and that includes most of the capacitors on the subboard here, even though the subboard is not a problem, at least right now. So that should be everything here. Just give it a little. We should unplug that too. You don't need the subboard. So give it a little wiggle. You need to take this subboard out, so you need to take off the potentiometers. And we also need to unscrew all of the terminal blocks. So we're basically back to square one. I had a couple ideas for what went wrong with this. It all comes down to capacitors, because capacitors are kind of the thing that goes. They're also kind of the hardest to test, so it's hard to really say if a fix fixes it. But basically, my idea is we have a couple capacitors over here that look kind of darker, so I'm wondering if maybe they have an internal short or something. Okay, if this just will move, and let's try to move it up here a bit. The thermal paste is doing its job. Yep. Oh, and we also have these grounding tabs. Right. So I'll set the thermal paste back on there. We have... that one should be free. It's whether the other one wants to come out. So we'll grab the cap off of here. That off of here. Unscrew it. So yeah, after that happened, I basically just said, whatever, we'll just recap the whole thing. Hopefully that'll fix the problems I've had. And then Hopefully that'll be the end of it. So, oh right, we have this power thing too. Switch. So it's about 3:40 here. I think I've got to be gone by about 6. So I'll see if I have enough time to do that. I didn't buy the capacitors for that just because I figured they're not really needed. Basically, I will grab Kapton tape right now. I will see if I can grab some before I forget. So I've got some Kapton tape here. This is a kind of bigger spool, but we'll see how it works. My pliers here. Let's get that started. Okay. So, all the thermal paste there. See, it's these screw heads here. I believe one of them was just touching the underside of the relay board. And you know, maybe that caused an issue too, I don't know. But we'll tape that off so it shouldn't do that anymore. And then basically just start her up. I'm going to just see if I can grab some there just to cover it. I don't know how well that's going to work. You might just have to leave it. Believe I have my, where did I put it? Oh, there we go. Down here. My little PCB holder. That'll let us spin around easier. Let's do that. Make sure it's squeezed together. Tighten them. And I guess we kind of want it this way because we don't want the... So we're going to move that out of the way, just temporarily. We do still have the power cable. We can just grab that and move it. Okay. So, bags of capacitors here, and the stuff here. So we will just get started on this. So, I think the first ones I want to do are, I believe it's up here, and I think it's, yeah, right there. Let's go up there. Those are our input capacitors. There's basically 2 capacitors, one large, one small. They filter out kind of 2 different frequencies, if that makes sense. They do more than that. Basically, the bigger ones are better at getting some of the bigger voltage spikes, and the smaller ones are better at the smaller. So, should get myself lots of slack here with the solder. Yeah, I don't know how much we'll be able to do. I'm hoping we'll be able to do a lot more than I think, but I'm not really sure. So, get the sucker out here. We'll see if this goes any faster. Go up there. I think that was actually pretty quick. Right. And Grab some good pliers. Okay. So let's see, 153. So, I have my tablet here. We will cross-reference the capacitors. Was that 153? No, 135. I can't read. So, tablet here. I have schematics. 135, 136. Right above the check mark there. Ceramic 0.1 UF. So we will check that. Linear diode, ceramic. We also got a replacement resistor for that R401 since it was heating up pretty bad. That's electrolytic. So 0.1 UF, double check that. 0.1 UF. These are 50 volt, which I believe should be fine because the input voltage is well, the transformer transforms it down to plus minus 35 volts, I believe. Hopefully that's not going to bite us back. It could have gone like 100 volts, but I don't think it needs 100 volts. And I believe the document says 50 volts for most things. So this one's kind of hard to fit in. We got everything above it, which is kind of why I'm doing it first. Oops. That slid right under there. So, over here. Let's try to widen that a bit more. I have my other pliers here too. Yeah, okay. So yeah, I think my plan is get this board recapped, see if I can get it functioning, and then once it's functioning, we'll put it back together, see if it works, and then probably off stream I will go and fix the subboard. There's dabbing emotes in. How do you get the dabbing emotes? Is that one of those community join things that you have to pay for? I'd like a dab. Oh, I can't. I hate this. Why is it so close? I say why is it so close, and I bought bigger capacitors. Where'd that even go? Alright, well, we'll wait on that for a second. Oh, it's down there. Okay. Grab it again. Oh, they're just there by default? Sweet. As every live streaming service needs a dabbing emote. Okay, this is kind of a pain. Try to bend it up in there, and then we need that wider. Sick. Okay, got that in. So fold those over. solder those in. Oh, need to push that up again. Let's hold one leg in, hopefully. Go up in there. Up in there. Hold it for a couple seconds. Okay, other one was these two, I believe. That one needs some fresh solder to let it suck up easier. Up there. I think that's pretty good. We'll see about that here. Try not to touch the thermal paste. And wiggle it out. Set that up there. Hands are faster than my eyes. Oh, they're over here. So yeah, the one thing that kind of scares me is the size of these. And that's 0.1 UF, that's C136, I believe. Should be the input capacitor, we're just doing a double check. Yep, 136 is up there. So yeah, I don't know if the size is going to matter. I hope not, because DigiKey really only had these smaller size, so I wonder if just maybe over the years the process has gotten smaller and we can make the parts smaller now, but it does kind of sketch me out. I also don't like how that's positioned, but let's go. That leg in there. Let's fit that one in there. And just shove her down in there. Okay. Fold them over. And solder them back in. I'll trim these all back at the end. It'll probably be easier to see them at the end too. And then those are the only, oh, we have a ceramic up there. C407. So I believe 407 is also a 0.1 UF. C407, 0.1 UF ceramic, yes. So that is beside the, yep, most upper. Let's go up there. Go up here. Get the solder sucker ready. See if that loosened it up enough. Yep, perfect. 0.1. .407 on the schematic. R407, C408, C407. That's just between -35 and ground, so that should be fine. There. Let's go up here. Up there. This one's also kind of a pain. If I didn't drop stuff on the floor as well. What needs to be fixed? So basically on the first live stream, I'll show you after I get this capacitor in. But basically I did smaller repairs that I thought were the issue. And they fixed part of it, but they didn't fix the full subwoofer. So I'll show you what I think it is right now and what I'm hoping it is. if that would just fit in there. But basically, so these two big things are capacitors. So are all these tiny little things. I'll bring it up. Lighting's not great because my phone's right in front of it. But all the tiny little silver things with the caps, cylindrical, they're capacitors. And so are these little disc things. This is also a capacitor. It obviously won't focus, but there's different types of capacitors. So is this green thing on the end. But electrolytic capacitors, they're kind of the most common for stuff like this. Like they're used for power and stuff. So these are the two giant capacitors that come in for power. Their job is to basically keep the voltage steady. So these kind of are the two main capacitors. If one of these fails, it can blow up the whole board, which likely is what happened here. So basically, before I replaced these two were leaking. That's why some of the stuff doesn't fit as well, because these are wider than the originals. But basically, they were leaking, so they're not. They wouldn't be doing their job of providing steady voltage, which means that anytime you have a voltage spike, so when you turn on the subwoofer, it'll spike. If another thing in the circuit comes on, it'll spike. So believe I have like I'm not sure how this apartment is set up, but I believe there's like a freezer on the same circuit as this. So every time that freezer turns on, a big voltage spike will happen. So I replaced those, and I replaced a couple transistors up in here and a couple diodes, hoping that would fix it, because I figured it was just dirty power, which partially fixed it. It plays for about a minute now, and then it'll turn back off. And basically, what I'm thinking is basically all these tiny little capacitors can also go bad. They're harder to see if they go bad because they're smaller, so they can internally short, which would be a dead short in the circuit. And the way capacitors work is they're actually a open circuit. They're not a short circuit. So if they do short circuit, that's very, very bad, because it's two arguably voltage rails that shouldn't ever like get in touch with each other. So what I'm wondering is if one of these capacitors shorted. So you can see, no, you can't really see. I don't really know if I can show it. But basically, there's capacitors here that are kind of darker than they should be. So it won't focus, but you can see the color there. It's kind of like a dark orange. There's kind of like a black portion to them. So kind of makes me think they've burnt out. Now, if they've burnt out, I could just replace them, but realistically, they could have other capacitors gone, and this whole thing is, I think, older than I am. So there's no real point to me being cheap. So I'm just gonna replace the whole. So there's an electrolytic. So it's a tiny little thing. And we'll suck out the solder for them so we can actually place a new one. So, suck out that. I don't know if we'll be able to get that one. Suck out that. Oh, there we go. Okay, perfect. So this was a 10 UF. 4.7, 22, 22, 0.47, 1 UF, 2.2. This isn't a 10 UF, is it? That's 100 UF, yeah, no. 447. I think this is it. 10 UF, yeah. I think I'm just gonna replace everything. Realistically, at this point, there's no reason not to. I bought all the capacitors I need to do this, so. But yeah, I don't really know the. Basically, this was a subwoofer I got for like. It was part of a surround sound set I got for $50. So realistically, you can't go wrong. So the surround sound system still works, and depending on how you view it, I've got this sub for like $25 or $5. But that's the negative side, yeah. So like, yeah, I kind of have it in me to fix it, because otherwise it's going to be up the wazoo if I buy another subwoofer, because subwoofers are like, I don't even know, like $100 a piece by themselves. So it's kind of a thing, if I don't need the best of the best, I just want something that does what it does. So I'm like, as for this board, I'm not doing increments, but there's sub boards that I bought capacitors for as well. Like these ones up here. There's capacitors on there. I bought the capacitors for it too, except the electrolytic, or the ceramic, because I don't think they need replacing on the subboard. What's the next one here? Oh, it's over there. Okay. So, like, I'm just gonna do this whole board because it should be done anyway. It should have been done a while ago, but I've never really done a recap in my life, and I didn't really know how often they need to be done. Oh, that was quick. So what's that one? 10 UF again. Okay. And just go. Yeah, so I don't know exactly what was wrong with it now, but you can see like this area is darker in the thumbnail of the video as well. Like this patch has been heating up, and like that's the audio goes directly through that. So if that heats up and shuts off, then no audio is getting played, basically. So that's what's kind of going wrong now. So I'll probably replace the transistors in there too. I replaced them last time, but if they're burnt out again, and I have, like, AliExpress only let me buy them in packs of 100, so I have like 200 of the transistors. So solder that back in, and then let's do that. Yeah, and the other reason I'm doing all of this is, I mean, I don't know I think these are like Jamicon capacitors or something. Something weird. I've never heard of the brand before. Probably like a Kenwood brand they use or something like that. Not like a brand, but like a distributor or something. Well, not distributor. I can't think of the word. But I'm assuming they had like an agreement with this company when it was first built. That, or someone's already replaced it, and I don't know the capacitor brands. This is another 10 UF. Guess we're just doing all the 10 UFs. So I'm replacing it with Nichicon capacitors, which is, I think that's how you say it. I don't know how to say Japanese names, but it's a Japanese brand. So if you've ever heard in the PC world Japanese capacitors, these are some of those. They're just known because Japanese is quality, like with everything else. So they should last longer. And I think for capacitors specifically, they're known because I think other brands, like back in like the 90s or something, I don't really know, I wasn't alive then, but I think I watched a YouTube video about it. I think back in like the oh, I don't like that pad. Oh. Let me just do. Yikes, okay. I'm gonna have to be careful. So one of the pads is lifting. Let's make sure we're not shorting there, and I think we'll be fine. I think it'll be fine. But basically, I think back in the 90s or something, there was a bunch of companies who were cheaping out on capacitors, and I think they started blowing up and kind of failing early. So I don't think this is one of them, because obviously it's lasted a while. Like, it's probably gone through multiple hands before I started using it, but come on. Come on, buddy. Come on. I need flux in there. Flux, doser and flux. Alright, getting in there? I don't think I can. Okay, that's gonna be a bit of a pain. One of the legs is out, one is not. So just make sure that's okay. There we go. That's another. That's 100 UF. What? Oh. Okay. Interesting. Don't know how I'm gonna fit that in there, but okay. Okay. Let's do a double check. C603. Yep, it's 100 UF. Okay. 220. UF. Okay. So cut these open. Okay, negative was holy stink. That's going to be impossible. Gonna have to sit up high or something. Okay, we got it in there. It just needs to be fed through. It is going to be hard. Okay, we're going to straighten this out. This might have to sit off to the side or something. Actually, why don't I just do it like that? It's gonna sit off high enough. As long as I make sure it's not shorted. That'll be much easier to one second, I'm gonna grab heat shrink. Because we want to make sure that's not going to short, so grab onto like that here. Just do like that there. So basically, just adding a couple heat shrink. See if I can get those to shrink down. Not really looking to get like a actual thing out. Oh man, shrink down. Oh man. Oh, wow, that's a first. Wow, we got the spam bots. Wow. I'm getting popular. I'm gonna have to delete those. Probably not right now after the live stream. But okay, set that in there. Set that in here. Set that in there. Okay, we will do that there. Okay, that should be good. I'll trim all of these off. Trim that off there. Make sure that's good. Just trim that one. Trim that one, trim that one, trim that one. Trim that one. Okay. There's also another 100 UF there, which is going to be a pain. Let's put flux on there. Rotate her around. Oops. Up over here, and just go up over here. Okay, just go grab it again. Okay, there's that. It's also in 100 UF. So that one we might be able to actually get. And I'm gonna try pumping those out just so we can try to get it. There. Okay, there we go. Much better. We're not going to be able to get that perfect, but I think that'll be good enough. Just go up here. There. Just go and snip it off. Okay, so that corner is all done. Now we can start working on this side. We're going to start with this easy capacitor right here. So that's going to be right there. Just grab some flux. We're going to have to clean this off after. Just warm her up. Slide her right out. And then, there we go. And that was also a 10 UF C508. Just want to do a double check. So again, I have the data sheet here. You can see we have C508 highlighted right there. Scroll over, electrolytic 10 UF. So that's these ones here. UF 22 UF. So yeah, 10 UF, 50 volts. Can't really see it on there, but cut it out of there. Take it off. And just go here. Feed it through. Oh, it needs a bit of a coercion. Oh, I thought we sucked it up. Huh. Guess it didn't get suctioned up fully. Or maybe it didn't. Maybe it was just pulled out. Anyway, feed it through here. Negative goes to the marked side. And fold it back. Solder it in. Give it some nice heat. Give it some warmth. There we go. Before I forget, I'm going to just delete those comments. YouTube Studio. Actually, I don't know if my channel. Go to here. Turn it off, and we're just going to delete those. Remove. Okie dokie. That should be all good. No one should be bothered by those scam bots now. Okay, so one capacitor there. We have this one here, C402, which is right there. And more flux, because we want to prevent any damage. Don't care about cleaning it up later, we'll have to do that anyway. So, heat her up, pull her out. Heat her up, slowly pull her out. What is this? 4.7 UF. So, we look through our bags here. We have a 47, nope. 220, 2.2, 1, 0.47, and a 4.7 bag here. So 4.7, you can see that. So grab those again. Grab one of those. 4.7. Let's do a that out. And 402. Slide that in. And just go there. Now our thing is getting loose, so squeeze that back in. Try to tighten it a bit more. And just go there. So, solder that back in. And just because I like to do a sandy check, what one was that? That was 402. I have it down on the left side here, 402, 4.7 UF. Yep, correct. We have, we'll do these ceramic ones. So we have 410, 406, and 408, I believe. I always forget. These ones are kind of a bugger. So when the silk screen isn't great, I usually go back to these schematics. So the ones I'm looking at replacing, above this highlight, C410, 406, 408. So I'll show you, scroll down again to the documents. C408 is ceramic 33 PF, C410 is 240 PF, and our C407 is another 0.1. So let's do our 0.1 first, since we have them out. We'll grab it here, bend it into place. Bend them out. Bend them back in. And 410 it was, right? 410. No, it was 407. So no, it was 406. But 406 was also 0.1 UF. So consult it again, just make sure we're not going insane. 406 is that top one there. It's the one that's also kind of dirty. I can also not really show it, but these big white things here are giant resistors. I believe they're in series with the output, so obviously they need to handle a lot of current. But there's little markings on this one too that are from the capacitor, so it makes me kind of think that they heated up a little bit past what they like to be. Just put more flux on there, flux on it all. You can clean it off later. Clean off our solder tip. Just add a bit of thing there. Just add a bit of new solder. Up over here. Okay. Just go up over. Kinda just want to do like a half and half, or I can kind of pull it out. So that's going to be this one here. Oh, sweet. Okay, that came out easy. So that is C406. There's a reason we do multiple sandy checks, and that's because you will make errors if you don't. So the reason I check over this 50 gazillion times is because I've made these errors before on previous projects. I think we tore up a bit of the pad there, but we should be fine. Set this in place. Okay. Fold them over. Up over there. Okay. solder it in place. Let's do that. Okay. Trim these off. We'll trim the others off too. Trim that off. Trim that off. Okay. So that was 406. We'll do 410 next. Yeah, I don't really like the look of it, so I was doing it halfway because I kind of wanted to pull it out with a pair of pliers. With this, you don't need to give it much pressure. It'll come out on its own. You just got to give it heat and a tiny, 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 tiny bit of pressure. Just so when it does get that heat, it'll release and pull with you. So, go up there. Okay, come on. There we go. Okay, this one can use a bit of solder more. Just add and let it flow in. Okay, so that's C10. C10. Or C410. C410 is 270 PF. So what's this one here? 270 PF. We have one single capacitor here. 270 PF. Set it in place here. Put it in there. There we go. Fold over the legs. Those are like that. Okay, and I'm just going to snap that off, snap that off. Okay, we want to make sure that's not going to short, because that would also be bad. Clean off my fingers because I keep hitting the thermal paste. And then we want to do C408. That's what it was. Set it here also. Add some flux. It was over here. That one there, I believe. So. Okay, ow, ow, ow. Who knew that stuff hurts when you heat it up? Grab that there, perfect. And C408 was 33 PF, so we are looking for 33 PF next. I think that was over here. 33 PF. I only need one. Okay. Now who knows too, because I didn't have the owner before this, or I wasn't the owner before this, and I'm pretty sure this has lived a way longer life than I have. Now what it actually did in that life, I don't know. But maybe someone did a repair earlier, and maybe it ended up, they put the wrong values in, and it worked at the time, but maybe it's not working now. Who really knows? I'm just hoping that this fixes it. Add heat to both of those. let it flow in. Heat to both of them, let it flow in. So I'm really hoping it fixes it, because I'd really just like to have bass back. Not that I'm huge on bass, but it does add to the experience, and when a song uses it well, I do enjoy it. So what's C404 and C405? 404 to 407 is still 0.1 UF, so we can do both of those with these capacitors here. Let's do, I don't need that many. That's 2 there. One in my hand, one fell down. So bend these out again too. Up out here. Up out here. So that's there and there. It's right there, yeah. And then, where is it? Go there, which is from, just like that, there. That's a weird capacitor location, okay. So up here. Okay, one's out. Oh, it's just there, okay. Sick, okay, so let's go and do that there. That's tearing up the pad. I want to just do like that. Okay, that'll work there. So, put these in. 404. Set that in there. C405. That in there. Okay, we'll trim all these back. Just like that, just gonna be just like that, just gonna be that, like that. Okay, we didn't trim, or there's still a thing there, okay. So next we'll do, that's 100 UF and that's 22 UF. So we'll do the 100 UF. So we have those out here. Let's do a double check. 100 UF, 35 volts. Oh, but that's 16 volts. That's totally fine. Okay, come on. Come out of the packaging. There we go. Oh, okay. I am over this repair. I just want this to work. Negative, down, and straighten that out and just go and believe it's, need to stop touching that. Zener diode, so it's right there. Okay. Put that there. Wiggle her out. Okay, there we go. So, solder sucker. Where is it? This one? Yeah. Perfect. Perfect. Clean off the tip. And negative side down. Negative side down. I'll just kind of put it off to the side here, mostly because we've still got that Zener diode, and that was another thing I bought. I don't want to replace that if I don't have to, because I didn't find an exact match, and I probably could have gone on AliExpress, but not really looking to do it off AliExpress, because AliExpress took a month last time, if not more. Which is fair. I can't really complain. They still have the parts, which is nice, but I just wish it could have been a bit faster. So that was our 100 UF. We want the, what was that, C1, C401? C401 is 100 UF, and what's that, 403? C403 is 22 UF, which is the capacitance on there, I believe. So just do a little wiggle out here, just add some heat. S wiggler out. S coercer, okay. 22 UF, perfect. We have that there, just suck out the other hole. Out of context. 22 UF, 22 UF, that would be it, right? Ceramic. That's 403, yep. 22 UF, 35 volts, same match. So I never mentioned it here, but if you're doing a recap on stuff, the main thing is to get the package right and the capacitance right. Now, by package, what I mean is your capacitor material. So, like these tin can ones are electrolytic. Your other ones are ceramic. There's probably some crossover of what you can use, but it's probably just best to use the closest to the original you can use. Other thing is you want the capacitance to match. So that's why we have the exact capacitance on the that's calculated out, because otherwise that starts messing with stuff, especially in audio circuits. Capacitance directly has an effect on filters and stuff. So if you have an audio filter to filter out certain frequencies, having a different capacitance will not filter out those frequencies properly, or it'll filter out too much. So that matters, but the one thing that doesn't matter so much is the voltage. Now, of course, you want the voltage it has or higher. So if you can only find alternatives for, say, a 16 volt capacitor that are only 50 volts, well, you can just end up replacing it with that 50 volt one, because the voltage rated for them is the maximum voltage, not the operating. So as long as you exceed that that maximum on the other one you're replacing, you're totally able to replace it. I have a monitor that I repaired with a, I think it was 3300. I think it was very similar to the capacitance of these two big tin cans. So that's a 10 UF. I believe the 10 UFs we have are here, right? 10 UF, 50 volts. So I had one that like it was a reasonable size capacitor, like a bit larger than these ones here that I've done, but like it was just in a monitor. Monitor was boot looping. I wanted a free monitor. I wanted a second monitor, but didn't want to pay. Oh, I've got to suck those out. That would be why. But it was basically boot looping. Didn't want to pay for a capacitor either, because it wasn't really worth that much as a monitor. It wasn't even 1080p. Had DVI, so I could use HDMI on it, but wasn't that great. But I had access to a bunch of capacitors and had to do research on it because I didn't know how to do that at first. But basically, it was like something like an 100-volt capacitor or something stupid ridiculous. It was an absolutely massive capacitor, largest capacitor I've ever seen. But just soldered extension wires to it. Soldered it back in, and the monitor still works to this day. It is still my second monitor. Do I want to use it? Not particularly. Eventually I'd like to replace it with a 1080p, but it works, and it was free, so I can't really complain. I don't know if we're going to clean this out much more than we have. Let's try to see if I can scrape around here. So these solder suckers get gummed up pretty easily. You got all the solder there with the flux, and it all combines and just kind of makes a mess. So I'm just trying to clean it out right now a bit. Hopefully that'll work. And I mean, I could use solder wick because solder wick's probably safer, but it also takes way more time. I don't know. Can't really tell. Let's go there. Good enough. As long as we can fit it through. Negative side. Just in there. Grab more solder for us. Keep saying us. Am I already a streamer where I say us? Okay. And trim those off. Trim that off. Okay, so C530 is one I've wanted to replace because it looks pretty bad. I wonder if it's the one causing the issue. So what does C530 say? C530 is another 0.1, so that's part of our one up over here. 0.1. Okay. I'll grab one of these out and just go there. Just wiggle it out. I think it's that one there. Let's go up. Oh, okay, that came out really quickly. Yeah, it's hard to say. There's one side that's definitely like warmer, but I don't know if I'd say it's blown because it's not like, it's obviously not damaged from the outside other than just the colors. And it doesn't look like it burnt up, so it's hard to say. And I don't know if that's from itself or from externally in the circuit. Which is why I'm recapping the whole thing, because I don't really know what it would be at this point, and I don't really have the time to investigate. Okay. There. Okay. Works well enough. Flip it over again. Holy stink, it's right in the friggin' center of the board. I also should turn down my mic, I think. I think I keep peaking. But come on. Come on. Fit in there. Come on. You little bugger. Okay, just go and fold that down there. Okay. Up there. Up there. Let's go up over there. Up over there. We're getting there. We're getting there. C502. 502 is 1 UF. I think I had one of those. 0.47. 1 UF. Yep, I have one of them. So that's C502. C502, we'll do that next. That one's right there. Yeah, and the other reason I can't tell if someone's been in here is there was one joint that looked like it was modified, like it didn't look factory, so it made me think someone else has been in here. But the other thing is the capacitors aren't on terribly straight. Now I know not every factory has them on straight, and there's errors in the design. I don't know, majority of them don't seem to be on very straight. And maybe it's just over the years they've been, not bent themselves, but if, like, maybe I hit them and bent them a tiny bit. And maybe someone else was in here and bent them a tiny bit. Maybe he didn't replace them. But, I don't know. I just kind of wonder sometimes. Negative goes to that side. Fold them over. Where is that one I just did? It was up over here, right? Okay, we already trimmed those back. I'm just gonna grab water for a second. Oh, actually, I have some. Okay, that works well enough. Okay. And I need some solder too. Did I touch that one? I don't know. Oh. So you can see how repetitive this gets. C152. Where's 152? Or I know where it is, but what's the capacitance? 152, also 1 UF. So that's our ceramic again. Or 0.1 UF. So I'll do 152. It's up there. Flux. Okay, there we go. Yeah. But it's a long process. Okay, there we go. Trim them off. Okay. C150. 150 is the one below? Oh no, 150 is ceramic. Yeah, so it's that one, okay. And it's also a 0.1. I'll get another one out here. And what's 139? 139 is an 100 UF again. Oh, that's gonna be a pain to fit. They put that right in the middle of everything. It's wonderful. It's 132A. No, it's a 47. C132. C506. C5. 506 is a 10. 501. 501 is a 2.2. So it's just that, or C1, 132, right? 132, yeah. So it's 139. That's just a big one. Okay, so we'll take both those out. I think it's that one here. This one and this one, I believe. Okay. Okay, there we go. The solder sucker here. Oh. There we go. So, fit this one in. That down, and we have 100 UF. Oh, that's satisfying. That's like a perfect fit. Cut that off, cut that off, cut that off, and cut that off. Okay. Just go and do 132. So that's a. We can actually grab it when we pull it out. I think it's that there, right? No. Oh, it's or the other way. Okay. So it's like that. Okay. There we go. 47 UF, right? 0.47, 2.2, 220, 47 UF. Okay. 10 volts. Did I not get the right? So what's this? That's a 47 volt, 50 volt. What is this on? 47 UF. So that's C132. C132. C139. 152. Where's C132? 150. $131. That's 132, right? C603, 604, 601, 605. C133. Is it connected here to R55? C132. I think I'm just gonna put that back. Almost certainly this 4710 volt is just gonna immediately pop itself. I don't think that's high enough power. Didn't clue into that when buying. Oh, come on. wait to put that back on. We'll set that aside. C506. C506, 10 UF again. Okay. Take that up there. Add a bit of flux. Okay. There we go. That one, C506, is 10 UF. Yeah, negative side up. C501 is a 2.2 UF, right? 2.2 UF. 100 volts, yep, that'll work. Okay, just grab that there. Here. Okay, there we go. Let's get that in there. That in there. Just go and solder it. Other than that, I think that's everything on this board, right? Obviously not that, because I'm not doing the Mylar. What's Q501? SC945, so I think I have a couple of those. We might replace that one too, because I don't know why it's got a yellow cap to it. So that's 502 and 501 and 502. Okay, we'll just replace both of those while we're at it. And they have their direction. Yep. Okay. Hey, there's one. There's two. Where's my... It's over here. We're gonna do this for these ones. This is a bit more annoying. Just like this here. They are C945. Which one are these ones? 733, so they want these ones, right? Do a double check. C945K, yep. I'll just do that there. Bend them into place. Hold this one on here. These long legs off. Okay. R401 is right there too. Just be. I think I see it there. Maybe that resistor was bad too. I don't know. I wanted to replace it last time, but they didn't give me the right part. That's a Zener diode. Zener diode. Oh, it's right here. Okay, let's grab that there. That there. Gold, red, black, brown. Okay, that's the right resistance. that there. Yeah, that resistor is also not looking great. It tested fine, but it's chipping apart here. So, oh, we also didn't get this capacitor, the 100 UF. Okay, we'll do that one too. Then we still got to put in that other one that we think is going to blow. So I'm not going to put in the new one, I don't think. It looks fine anyway, and one capacitor should be fine. So that's 100 UF. I think it's under the pile here. No, maybe not. Where'd they go? I got a stuffy notes too, and I don't know. Oh, they're right here. Chat would have seen them the whole time. So that's 100 UF. Okay. I think I actually cleaned it out. Nope. Frig, I'm so lost. Where's my stuff? Really need to get this organized. That's another thing I need to do. It's over here. Okay. I think it was that one there. Okay. Here and just go up in here. Okay. Okay, that should be fine. Just enough to get it through. Negative bottom side down. Up, down, in there. Okay. Up, down, there. Oh, look, more spam bots. Perfect. I'll get those deleted in a second. Wow, perfect. Remove, report. Did that not delete it? I don't think it deleted it. Why would it not do that? How do we even, man? Edit video or something? No. I don't know how to get to the live stream studio. Anyway. Oh, okay, there it is. Remove. Okay, there we go. That should be gone. So, back to the recapping. Do that. Ah, I keep putting my fingers right in the thermal paste. Okay. What's Q 403 and 401, right? Okay. Q 403 and 401, they're different ones. So 403 is the 9.5. So that's this one here. Right? $945, yeah. Get another one of these set up. We'll replace Q403 with it again because that one was getting hot. And if it's burned again, we just want to replace it. So grab it in here. Grab some flux. And just dose her. Oh. Let go there. Great commentary I have. I think it's this one, right? Yeah. That one there. There we go. Solder wick again. Just cut off the old stuff. Get this stuff here. Stuff there. Wicks up really good. Screw 945. Fit it in here. Just go up in there. Okay, let's do a desolder again of the next one up since it was getting pretty hot. Add some flux. Okay, there we go. Okay, there we go. Okay, I think that's everything, right? I don't. Oh, there's 151. Let's see 151. 151 is another 0.1, so we can replace that. We will do just about everything we can. Try to eliminate all the possibilities of it failing again. So I'll see if it works. Good enough. As long as I can fit it in there. Okay, let's go up in there. Okay, do a double check around here. I don't see any old ceramics, don't see any old electrolytics on this side. Yeah, that one's sticking off the board because it wouldn't fit, but that's okay. We have new resistor there. We have new transistors that were causing issues. We have new transistors there. These ones I'm not going to touch. We need to solder in C132. All of the blacks should be aligned to the negative side of the board, right? Believe so. I was paying attention when I put them in anyway. Negative side there, and that's the negative side over there, negative side over there, negative side over there, negative up, negative right, negative down, negative right, negative up. Okay. As far as I can see, that's correct. We will solder in C132 again. Negative is down. Fits in there pretty nicely. Oh, shoot. We ripped that pad. Okay, we gotta watch that. Oh, it's not ripped off yet, but it's getting there. So we'll be careful putting that back on. Put stuff on there. Okay. Should be good there. Okay, I'm gonna clean it off then. This is isopropyl alcohol, IPA. That's with a old toothbrush. Let's try to clean some of this flux off. Let's hope that works. Another one with like a cleaner. Clean off of there too. I don't think it's going to be perfect, but I think that'll be good enough. Okay. put the cap back on that. Okay, we'll set that aside. Move this off the side. Got capacitors all in with our screws. That'll be fine. Just move that. Just go do just this up here. Where'd those screws go? They weren't these ones, were they? No. Are they? I don't think they were. No, no, I see them here. They're under the other side. Yep, this side here. Okay. Just like this up here. See if it works. Oh, I don't want that fully on yet. Forgot to put the other board on. Wiggle that off. Just like that there. Okay, I'm just gonna remove that. I'm sorry. I like it, but it's nice to have them fit between each other, but it's not really working. Just like that there. It's just going down. Just slide that down a bit. Fit that in there. Just go and slide that back. Every time I see my head on my second monitor, I'm freaked out. Okay, there's that. Go up here. Go up here. Okay, let's go up in there. Go up in there. Okay. Oh, I still have the desktop audio on for you guys. So you heard that too. Loud and clear. Okay. Okay, let's hope this time it works. Okay, let's start these. I know I'm putting it all together and stuff, but I don't really have a choice to do it without it all together. Don't want it shortened, and it's not really places to put it, especially with the cabling. So plug that back in. Plug that back in. And before I do a full reassembly, let's see if anything pops or anything shorts or anything like that. Let's just go and get that last screw in. So we got about 20 minutes to wrap this up. Okay. Let's go and plug it in up behind here. Wrong way, no, right way. Let's plug that in. Let's go. Moment of truth. Well, nothing's popping. At least so far. Well, that's partly good. That means I didn't mess anything up. At least with the things. So let's put this back on. Again, I have to like reassemble this all because there's not really a choice otherwise, because the subwoofer is enclosed compared to the control board. So I'll get the lid here for that. Go and put that on here. Set it like that and just go to the side, open it up. Oh, come on. You know you want to. Okay, that should be clicked on there. Okay. So I have these 6 screws here. I'm not going to put them in all the way. Just enough so it's closed. I'll probably put 2 in the corners all the way. And the other one's just started. Where's my screwdriver? Screwdriver here. Okay. I think it's here, right? Yeah. Oh, shoot. Okay, that one can go all the way in. This one can go all the way in. The others, I'm just going to get started. It's friggin' nerve-wracking again. I don't like this part. Okay, I'll grab the actual box. Go up there. Let's go up there. Okay. Can't really show you because it's too big. I'll bring it on the desk in a second. But basically, plug those in. Set that in place. Just move these out of the way. And here. So I have it That's what I was afraid of. I almost think we need new relay. For sanity. Turn on my subwoofer. Let's do some tests. I need to. I'll mute it for you guys because I don't know if copyright will like it. Yeah, what I thought. It's not working. So just go and unplug that. Move that off of here. And back to the drawing board. Unscrew these. Shit. What's this side I need, right? Let's go up here. I'm gonna take this one off again. Nothing can go right, can it? Can't just be a simple fix. Shoot. Nothing we missed, right? Nothing shortened. There's one awfully close, but I don't think it's shortened. Let's trim it back anyway. Maybe it's just 110 or something shorting to the ground. We're gonna cover this whole thing in capped on tape. Just go here. Just go there. About at my wit's end if this doesn't work. Yeah, man. That'll work well enough. Just as a covering. Screw one of them in. Up in there. Up in there. It's not even clicking. What's it gonna do? Okay, well I'm gonna have to end stream here because I have other stuff to do, but Oh, that's kind of a disappointing end. Not sure if I'll do another stream. We'll see. Just kind of hoping it